Alright, today we're going to be reviewing for your end of module test. So we're going to start by going over all these questions that you guys should have done yesterday. So the first one says, Diamond used a number line to add. She started counting at 10, then she counted until she was on the number -4 on the number line. If Diamond is modeling addition, what number did she add to 10? Use the number line below to model your answer. So right here, we know that we all start at 0. What we can do is draw our arrow to 10. And it says she counted until she was at -4. So you draw another arrow from there all the way to -4. So the number that she added to this would have to be whatever that is, right? So then if you're going from 10 all the way to -4, that would have to be -14. And here you can do 10 plus -14. It's a -4. All you're looking at is at how far it takes to go from 10 to -4. Yeah. So we can move on to the next question. So B is the right real world story problem that would fit that situation. If I got, again, 10 plus -14 equals -4. We could write something like, if someone earned $10 and then, let's say they spent $14 or something, somehow, they'd be in debt by $4, right? Or you can say maybe a person hiked up 10 yards on a hike, and then they hiked down 14 yards, and then you'd see that they're at -4 below sea level. So something like that. So we can look at question C. Use the absolute value to express the distance between 10 and -4. So you remember, to show the distance between two numbers, right there, all we do is you write 10, subtract the other one, the first number subtract the other one, and you gotta put it inside the absolute value bars. So here we know that subtracting -4 is the same thing as adding 4. So 10 plus 4 is 14. And since it says the distance, the reason we put the absolute value is to show that it's representing distance, and distance has to always be positive. So that's why the absolute value of 14 is going to be 14. So you can say 10 and -4 are 14 units apart. So hopefully that's clear enough for everybody. We can move on to the next one. Alright, looking at number 2. This is what value of A would make the equation a true statement. Explain how you arrived at your solution. So if we added these two fractions together, let's do that first. Right here, I got to get a common denominator, which would be 12, right? So I got to multiply the first one by top and bottom by 3. And then I got to multiply the second fraction by 4 and 4. So I'll get -9/12 plus 16/12 and plus A equals 0. So here we gotta add, let's continue adding these two. Alright, here we know our denominator is gonna be the same, 12, and I'm really just gonna be adding the -9 and the positive 16, which that should get us 7, because you've got a negative and a positive. To add add them just like we add regular whole numbers. We do the bigger one, which is 16, subtract the smaller one, 9, we get 7. And it's positive 7 because, again here, the positive number is bigger than the negative. Alright, so we got this. We kind of pretty much made this equation a lot more simple down here, so it's kind of easier to get our answer. So it says, what value of A would make this equation true? So what does A have to be so that this whole side is indeed equal to 0? So again, right there, that's just additive inverses, right? So we know that A just has to be the additive inverse of 7/12, which would just be negative 7/12. So then, that's your answer right there. We know that A has to be negative 7/12 because then positive 7/12 and negative 7/12 combine to make 0, and it makes this equation, or I guess this equation, true. And it's explained. So this comes up, when this comes up, or if it comes up on the test tomorrow, you guys can say, you guys gotta make sure you guys explain. Don't just show your work. Doing this is not enough. You guys gotta write a little explanation. You could say A has to be negative 7/12 because that's the additive inverse of 7/12, and they combine, or they add to get 0. Hopefully you guys will read that, and we can pause it if you guys need, and then we can move on to the next one. So moving on to number 3. Just waiting for the load, having some technical difficulties. Alright, let's look at number 3. So every month, Miss Thomas pays her car loan through automatic payments with her withdrawals from her savings account. She pays the same amount on her car loan each month. At the end of the year, her savings account balance changed by negative $2,931 from the payments made on her car loan. Right here says, what is the change in Ms. Thomas's savings account each month? So right there, what we could do is, if the change is negative 2,931 for the whole year, we're trying to figure out for each month. So simply there, we just divide by 12. And for this, you guys can use a calculator on the test if it came up. I gotta do that real quick. So 229.31 divided by 12. That'll get you $244 and $2.25. But remember right here, we got a negative divided by a positive. By now, you guys should know that negative divided by a positive should get you a negative. So that answers the question. It says, what is the change in her savings account? You can say the change in her account each month is negative $244.25. Make sure you put negative, because if you put just positive, it's not really indicating if it's increasing or decreasing. If you put a negative there, that kind of shows you that the change, their withdrawals, they're decreasing the amount in her savings account. So again, important thing is that negative. All right, let's look at the next part. Let me just check if I did that real quick. Negative 29.31 divided by 12. I think I might have got the wrong answer. Alright, that's fine. You might have got, maybe you would have got a different answer. I think I did it right. You guys can decide. Let's go to B. So describe the total change to her savings account after making 6 monthly payments on a car loan. Model your answer using a number sentence. That just means write an equation to get the answer. So if you know that each month her account changes by that much, and it's saying for 6 months, after 6 months, all you gotta do is just multiply that by 6, and then you would get negative $1,465.50. And negative because you got right here a negative times a positive, just like before, gets you a negative. So that'd be an answer for that. Alright, let's look at the next part. C. This is Jesse and Maya are playing the integer card game. The card in Jesse's hands are shown below. What is the total score of Jesse's hand? Support your answer by showing your work. Right here, you could really just write 3 plus negative 5 plus 9 plus negative 6. You know, right here, you can add those two, get negative 2. The negative 2 and the 9 gets you positive 7, and you add that to negative 6. And get 1. So make sure you guys have 1 for that. So put a 1, keep note of that. So part B says Jesse picks up 2 more cards, but they do not affect his total overall point total. State the value of each of the 2 cards and tell why they do not affect his point total. So right here, he has a sum of 1, and he picks up 2 more cards, and still somehow 1. That means these numbers gotta somehow add to 0, because then you got 1 plus 0 just equals 1. Alright? So we pretty much gotta find 2 numbers that add up to get 0. So these are just additive inverses. I could come up with negative 2 and positive 2. That makes 0. I can just make negative 7 and positive 7. As long as the 2 numbers you chose are additive inverses, then that'll show that it won't affect his point total. Pretty straightforward. Let's see, looking at C. Complete Jesse's new hand to make his total score equal to 0. What must the value of the card, or the question card be? Explain how you arrived at your answer. That's pretty easy. We just know that 4 and negative 6 makes negative 2. So if you're trying to get to 0, just know that this has to be additive inverse is 2. I think these are pretty easy questions that you guys should have gotten already. Alright, look at number 5. Michael's father bought him a 16-foot board to cut into shelves for his bedroom. Michael plans to cut the board into 11 equal size lengths for his shelves. The saw blade that Michael used will will change the length of the board by negative 0.125 inches for each cut. How will this affect the total length of his board? So, if you're thinking about this, let's see. So, let's say, let's draw a visual to help you guys see it. Let's say this is a 16-foot board. He's trying to cut it into 11 equal side lengths for the shelves. So if we're cutting into 11 pieces, we know that each time he cuts it, he loses this much from each cut. So what we gotta do is we gotta figure out how many times does he have to cut the board. So I'm cutting into 11 pieces. Yeah, that's one cut. 2, 3, 4, 5, 6, 7, 8, 9, 10. Is that 11 pieces? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, so that's 11 pieces, right? But we're looking back at how many times do we cut it? We cut it once, twice, 3 times, 4, 5, 6, 7, 8, 9, 10. So you have to cut it 10 times to make 11 pieces. So right here you have to do, if you know that you're losing this much of the board every time you cut it, you just got to multiply that by 10. And that'll get you negative 1.25 inches will be lost. And just kind of knowing that is when you're thinking about how many pieces you're cutting into. So let's look at a smaller example. Let's say if I want to cut this board into 3 pieces, how many times do I gotta cut it? 1, 2, right? So the number of times you cut it is always 1 less than the number of pieces you want. Alright, let's look at the next problem. So it says after making his cuts, what was the exact length of each shelf be? So if you know it's a 16-foot board, and earlier he lost, what was that? He lost negative 0.125. So again, let's see, he loses negative 0.125 each time he cuts it, and he cuts it 10 times. So that means he loses negative 1.25 inches. All right, and going back real quick, the board was 16 feet. What we could do there is 16, change the 16 feet into inches by multiplying that by 12. And 16 times 12 is 192 inches. So originally the whole board was 192 inches. We know that after cutting it 10 times, he loses this much. So we subtract 1.25 from it. You get 190.75 inches. But that's what's total after he cuts it 10 times. Remember, he's cutting into 11 pieces. So what we got to do there is to figure out how long each shelf would be. You got to divide that by 11. Just rounded to 17.34 inches. So 17.34 inches for each shelf. So let's see, just to recap that. Going back to the other problem, we saw that he loses this much every time he cuts it, and he has to cut it 10 times to cut it into 11 pieces. So in total, he will lose this much after cutting it. That's kind of like the sawdust that he's losing from the wood every time after he cuts it 10 times. And we know that the whole wood, it was 16 feet. We got multiplied by 12 to get 192 inches. So the whole wood is that long. We can just do that, subtract what he loses to get what's left after he loses all the sawdust. Then we got to divide that by 11 because there's 11 shelves. So for each shelf right here, each shelf, we about 17.34. Alright, so we got few more. Alright, Brian and Jeanette were playing the integer card game, like the one you played in class. I know we haven't played that, but the one that we mentioned in class. They were practicing and adding and subtracting integers. Jeanette had a score of -10. Brian took away one of Jeanette's cards. He showed it to her. It was a -8. Jeanette recalculated her score to be -2. But Brian disagreed. He said that the score should be -18 instead. Read their conversation and answer the question below. No, Jeanette. Removing a negative card means the same thing as subtracting a positive. So is that true? Removing a negative means the same thing as subtracting a positive. So here, -10 minus -8 is -18. So he's saying that -10 minus -8 equals -18. Alright, let's hold that for now. And then Jeanette says, it does not. Removing a negative card is the same as adding the same positive card. My score will go up. -10 minus -8 is 2, or is -2. So she's saying that removing a negative card is the same as adding the same card. So she's saying that -10 subtract -8 is actually 2. It's based on the disagreement who, if anyone, is right. So you guys just pretty much got to determine which of these equations are correct. And we talked about that, right? We talked about removing a negative or taking away a negative here is really the same thing as adding a positive, right? Because I could really just rewrite this one as -10 plus +8. Subtracting -8 is the same thing as adding a +8. And then that, it should be -2. And I should have put -2 up here. So we would say that this person is correct. Whoever that is, that's Jeanette, it looks like. And then write your little explanation. I guess you'll all be able to do that. Alright, let's see. Let's move it on to number 7. Alright, the table below shows the temperature changes Monday morning in Bedford, New York, over a 4-hour period after a cold front came through. If the beginning temperature was -13 at 5 a.m., what's the temperature at 9 a.m.? So if the beginning temperature was -13, right? So what was the temperature at 9 a.m.? So here, these aren't the temperatures. These are the change in temperature. So if at 5 a.m. is -13, and right here it tells you it's going to go down 3 more. So that gets you to -16 at 6 a.m. And then it's going to go down 2 more degrees. So it'll be down to -18. But then finally then here's going to go down 6 more degrees, so that'll take you to -24. And then lastly, it finally starts going up in the last hour to get to 9 a.m. You could add 7. So you do -24 plus 7 gets you -17. That should be good, I think. Alright, let's look at... So we got -17 as our temperature. So in the same cold front hit Hartford, Connecticut the next morning, the temperature dropped by 7 each hour from 5 a.m. to 9 a.m. What is the beginning temperature at 5 a.m.? What was the beginning temperature at 5 a.m. if the temperature at 9 a.m. was -10 degrees? So it drops 7 degrees each hour from 5 to 9. So that's 4 hours, right? And drops 7 degrees. So it was at 9 a.m. is 10 degrees. and they're trying to figure out what's the beginning temperature. If it's dropping 7 degrees each hour, if you're trying to go backwards, it's like you're actually adding 7 right here a bunch of times. 4 times because it's 4 hours. So let's see. So yeah, again, just we're adding 7 because every hour from 5 to 9 it drops 10. But here we're going from 9 a.m. back to 5 a.m. So you're going backwards, so you do the opposite. So you add 7 a bunch of times. And here you got -10. All those 7 just makes 28. And that should get you 18, right? And you can kind of check it also if it's at 5 a.m. it's 18. Check it by going down 7 a bunch of times. And then hopefully that should get you the right answer at -10 degrees. All right, one last problem. Hopefully everyone's still awake. All right, so let's see. C, in answering part B, Josiah and Kate used different methods. Josiah said his model involved multiplication, while Kate said she did not use multiplication. Both students arrived in the correct answer. How is this possible? So here, we got Josiah, and then we got Kate. Josiah said multiplication, right? It's kind of like what we did. We could, it was -10. You're adding 7 for 4 hours right here. So -10 plus 28 like that. And then we get positive 18. Yeah, then Kate says she did not use multiplication. She just pretty much added it straight through, right? -7 or -10 plus 7 plus 7 plus 7 plus 7, and that will eventually get you to 18 also. So both is possible because we know that multiplication is just really just repeated addition. All right, hopefully that should get you guys ready for your end of module test tomorrow. So make sure you guys review this, study, do all that good stuff. And good luck tomorrow. Goodbye.